So there's actually a bit of a tangent, but it's a related tangent that I want to mention as we're kind of easing into our next unit. So the goal is to find the mass of this guy. And you go mass, you go, okay, grams, kilograms. I need to find how many essentially atoms are in here. That's what mass is. It's a measure of how much stuff is in here. And there's actually two different kinds of mass though. There's inertial mass, like inertia with an L at the end. And this is really a measure of the resistance to changes in movement. So it's a measure of the resistance to changes. I'll use a delta because I'm lazy. In movement. Changes in movement, that really means acceleration. And so really, I guess in an equation term, that would be F net equals ma. A net force is going to cause a change in the movement. It's going to make something accelerate. So if you have more mass, it's going to take a heck of a lot more force to get the thing to accelerate, right? Now, there's another kind of mass, and it's gravitational mass. And gravitational mass is really, it's a measure of the attraction between objects. Now, I'm not talking about attraction like that boy or girl you saw walking by in the mall. No, we don't have a mall here. But really, it's how two different objects that have mass do in fact attract each other. It's why you are sitting in your chair or laying down or standing compared to just flying up about the room and like leaving the atmosphere and like floating off into space and dying, right? And so it's a measure of attraction between objects because oddly enough, this pen and this blob of clay actually are attracted to each other. Now, the neat thing is that these are two very different concepts. Now, the great thing about it is these two values actually are the same. And there's a force of gravity equation that's not just mg. This mg is actually just on Earth. The version of gravity that works everywhere in the universe uses this big G, it's a gravitational constant, and then it uses the mass of one object, the mass of the second, divided by the square of the distance between them, okay? Now, the neat thing is m1 for us is usually Earth. Your distance between you and Earth doesn't really change, and big G doesn't change. So really, we usually lump all three of these together into one thing that we call this little g here, is the whole idea. And now that's an odd thing, but the cool thing about it, and we'll call this then your M2, you are the second object in that system then, these two masses are the same. As far as all measurements, as far as all data has really kind of given us, all experimentation, is that these two have the same value, but they're two very different concepts that I just want you to be aware of. So this lab, the entire goal, this is kind of an interesting thinking challenge lab. The entire goal is to find out the mass of this clay blob. That's really all I'm asking you to do. But the weird thing is I'm giving you a set of known masses, because again, we have no idea what this guy is, a stopwatch, so you can just time stuff, a wad of paper, 2 C-clamps, and this guy. This is essentially a spring. I know it doesn't look like a spring, but we have this aluminum little basket, this aluminum basket that's cut open at the end, and then they're attached by these two thin, similar, almost identical little just strips of metal. And so, if I do, it goes crazy. And so, all I'm gonna do is I'm gonna take the data and I need you to figure out how to do it, how to make it work. So here we go with 1,000 grams. All right. I'm not even gonna use my stopwatch for anything. I'm gonna put it over here. And okay, I think that was enough awkward waiting. We'll go with the 500. I might need another wad of paper actually here, we'll see. Okay, I think that was enough awkward waiting. Let's go with a 200. Actually, let's tape it down so it does not move, and we'll have to, well, neglect the mass of the tape, because of course, if I tape this, I am going to make the thing heavier. That is undeniable. Okay. Okay, so now we've done 1,000, we've done 500, we've done 200. What about 400? Okay, so we've done 1,000, 500, 400, 200. Let's try 300 as well. I think this should hopefully give us enough data to actually figure it out. And again, we're going to have to ignore kind of the mass of the paper and tape. All right, now the whole goal of this is to find the mass of the clay blob. So why haven't I used the clay blob? Well, we wanted to get some baselines, maybe, I don't know, to compare to, I hope you're maybe thinking. So let's smush our clay blob in here. Again, we don't want it to wiggle. If it's gonna wiggle, that's gonna throw off everything. So we'll go ahead and tape this guy in even. And here we go. Okay, now that was pretty quick. You might need to put that down on slow-mo. I'll see if I can slow down the frame rate. Maybe I'll even try it again, just doing the video in slow motion to see if that works. But that's it. That's all I'm giving you. I need you to figure out the mass of this clay blob. Thanks.